to the first round of interview questions. So basically, in first round of interview, they have like 5 questions. First one is a write a SQL query to find the top 3 most sold product in the last 30 days. So how do you guys think it and apply? So basically, you need to understand questions. So when I say last 30 days, so we need to apply filter. Okay. And what else this is? Given a sales table. So let's assume this is fact sales. Okay. And top 3 most sold products, right? So top 3 most product. I think we can have like product ID and the sum of the amount, right? And then we can do a rank or something like that. Okay. So let's go through this one. So basically this is transaction table and the total sold item count and product the same. And last 30 days, current day minus interval 30 days, item and total decrement. So top item, I found it this way. Guys, there may be multiple ways to do. You can do it. So please try it. It's very, very important. SQL is the skills is very, very important, right? Now, given given a sales table, optimize low query performance. So how you guys are doing, right? Now, let's say you are here. How you guys will improve the performance of slow query, right? So first, what I think is apply partition based on user query, right? We can do that way. The second one, what do you think? Do incremental load, that is load, and some kind of sorting techniques. Basically, sorting is techniques when like some heavily distributed. So we have a number of distributed system, and one all the distributed system it's a consist of nodes. So each nodes is not working means some nodes has a heavy workloads because of the solving this problem and can avoid can. So this is the technique I can think, right? So you guys can think and then apply. So I think only like the clustering, partitioning, and so on. Use partitioning, sales dates. So first important, right? Partition by date, avoid the scanning, full table scan. We can remove the full table scan. And now next part is now modify the query, and it might be simple, right? Third one is caching and speed of repeating query. So if you use the query repeating, right, we can use caching technique to improve the performance, right? So this query is being used many places, right? So this data frame, I just cache it and store into memory and it will help, right? And so this is beneficial. Speed up subsequent query in the same data sets. The third one, implement incremental load, which I talk, right? So here, if you see, we can create intermediate tables, and incremental means sales date. Let's say I have sales data T minus 2 means, and then today I'm going to load this data. So max of this date, from this table, we find yesterday what was the date. From after that dates, we just load into the same table. Benefit, it will only process new data, reduce the computation cost, right? You guys understand this one. And the fourth one, I just said sorting techniques, right? So if some product have too much data, sorting distribution load evenly, right? So concat product ID floor random number we generate and multiply by 10. And this one you can check like what this will do and sorted product key. So basically idea is here, if the product ID is 1, then it will generate only 1 numbers. If product ID have like it will generate 1 to 10, so it will have some kind of, heavy load redistribute again, right? So this is also prevent hot partition to where the few product IDs dominates, right? So this is also we do. Okay, so these are the benefit which I talk. Now you guys have many things, other things you can also talk, right? So now the next part, design the star schema of e-commerce systems. This is very, very important. I think I might have given my previous lecture, but what I can think, okay, let's talk. So this is star schema. So fact table, fact, let's say fact sales, and then we can have subsequent sales means we have item product table, like each sales have a one product they are selling, and so this is product dimension, and similarly we have store dimension, similarly we have seller dimension, seller or what we can say supplier or seller, and similarly we can have date, and some way we can have, I think each product might, this is like this way can have, I mean this is my thinking, and then we can see the what is the solution. This is the fact table, and these are the all dimension table, and joining this together, yeah. So now let's see my answer how I did before. So star schema consists of central fact table which contain the transaction data and multiple dimension table which provide a descriptive details of transaction, right? So this is the product table, product ID, product name, category, brand, supplier. Supplier or seller is same. Similarly, we have item master table, item ID, product ID, item SKU, item color, size, date table, dim store, and this is the table which we talk. So basically fact table, dimension product, item master, dim store, this on. So this is fast query, pre-joined structure, speed up aggregation, easy reporting, simple join for BI, scalability. Now, okay, so this is the very, very important question which I talk. Now I'm going to talk about, so now, okay, so now it is fine. You guys are clear, right? This one. Now they might ask you, what is SCD type 1, SCD type 2? So how you guys are solving? So I will remove this one. So SCD is nothing but slowly changing dimension for its use for mostly dimension modeling. Dimension kind of table like customer table, product table. It's very important. So SCD 1. Let's say it is customer table. And I moved from Singapore to Bangkok. So in that case, I will have only one record for latest my location. Okay. In SCD2, we will have all the historical data, right? And it also have only one active and all historical, like it should have started, it should have ended, it should have active flag, something like that. And it is handled by date. So this is what I can tell. Now let's go to the my questions. So handling slowly changing dimension SCD1 2, slowly changing SCD2 used for handle changes of dimension table over the time. Here are the SCD2, SCD1 is override existing data. Use case when the historical change doesn't matter in its latest data. Approach is, I mean, if key already exists, override the existing key. If key is not exists, the new record, right? So here is the things, right? So I am merging dimension customer as a target using staging customer as a source. Okay, use merge. So try to remember this syntax. It's very, very important using this one on this, on and this and this. When match, then update, right? When not match, then insert. Advantage, simple and fast. Disadvantage is only keep the history record. Okay. Right. Now let's talk about next part, SCD2. So as I said, it's a historical must be track approach. is keep multiple records, and the customer, it should know the primary key. That's fine. And first, what we use started, ended, and active flag for version control. So table structure std2, you see customer ID and started, ended, and active. This is very, very important. It's y and some company put 1 and 0, some is 1 or 0 SQL. So what we do, first we will update previous record, current day -1, and the new record we are going to add here. So advantage is the full history manage. Disadvantage, it's over the time, storage will increase, query will be slow. Okay. Now the next question, I'm going to ask you guys how you guys are going to do. So guys, please practice before seeing my answer. I'm also doing practice like coding. Given a data customer transaction, calculate rolling. Given a customer transaction means a transaction data, rolling 7 days average sales. Calculate rolling 7 days. Given a data of customer transaction, calculate 7 days average sales. So rolling we use rolling we use OLAP function like rank or similar. Now it is asking last 7 days, so we can use like rollup function, which is called sum amount. Now each customer wise, right? So I think it should be over order by partition by customer. Each customer they want to see custody and okay, partition by this one, and the date range will be like current day -6 to till current day, something like that. So let's check our solution. This is what I can think, but you guys give the correct syntax, so interview will have the good impression. That's what I feel. So yeah, what I did, customer ID, transaction date. So we need to find each day wise, right? Data set customer transaction, calculate rolling 7. So rolling 7 is order cost, order by transaction day, order by transaction day, row between 6 preceding and current row. And this is average, so we divide by 7, rolling 7 days average. This is what we got, right? So guys, this is the first challenge, and please like and subscribe my channel. I'm going to have the next round of interview, which is